Right, this is January 07 Module 2, AS2. And it tells you Table 1.1 gives the names of some regions of the electromagnetic spectrum or a typical wavelength within a region. The regions are not in order of wavelength or frequency. Complete the table by adding an appropriate name or a corresponding wavelength in the blank spaces. Okay, now the first one there is radio waves, and you're being asked for a typical wavelength. Now you know radio waves are the longest, and they can range from millimeters up to kilometers. So if you put something in the middle of that, say 1 meter in there, in the mark scheme they're allowing you greater than 1 millimeter, 10 to the minus 3 meters. For gamma radiation is the shortest, and again that's something that you should learn off. And a good one to learn off is 1 by 10 to the minus 12, or 1 picometer. But in the mark scheme it says if anything less than 10 to the minus 10 meters. Now the next one is 5 by 10 to the minus 7. And if you rewrote that in terms of nanometers, that's actually 500 nanometers. And then that should remind you that light is 400 to 700 nanometers. So this one is light. And then infrared is just greater, or sorry, it is a wavelength just greater than red light. And red light has a wavelength of 700 nanometers, so anything greater than 700 nanometers, and I wouldn't go too much further than that, maybe say 900 nanometers, or 9 by 10 to the minus 7. In the mark scheme, they allow you 7 by 10 to the minus 7, which is your 700 nanometers, up to 10 to the minus 4 meters. Next part of the question, calculate the wavelength of an X-ray, which is a frequency of 1.5 by 10 to the 14 hertz. So you're going to use V is equal to lambda f. You know that V is the speed of light, which is 3 by 10 to the 8. And if you're not sure of that, you can look that up in your exam booklet. And therefore, we're looking for wavelength. So wavelength is V over f, which is 3 by 10 to the 8. Divided by 1.5 by 10 to the 16. And that's going to give you 2 by 10 to the minus 8 meters. Visible light waves may be plane polarized. Describe the meaning of the term plane polarized. And here again, we have met that question not that long ago there. And this does come up very often. So a plane polarized wave is one where the vibrations are restricted to one plane. Only. State one conclusion regarding the property of the waves which may be made from this statement. Well, we know that those types of waves have to be transverse waves, because longitudinal waves can't be plane polarized. Transverse.